Critical path analysis involves looking at a project and all of the activities needed to complete that project and working out which ones are critical. And what I mean by that is these critical activities are the ones which we can't afford to have any delay with, because if they get delayed, they're going to delay the length of the project. Now you might say, why aren't all activities critical? If you look at this example, and this is a network where each activity is shown as an edge, you can see that activity A takes 3 minutes, but while that water is boiling, we can be making a sandwich because the kettle's on, and you can be making a sandwich which might take 5 minutes. You can see these numbers represent how long the activities take. So because these activities are occurring at the same time, some of them are going to be more important than others in getting completed. Now let's have a look at what I mean by earliest start time and latest start time. The earliest start time of an activity at the beginning of the project is 0. So what we'll do here is we'll mark in on this first activity, which is boiling water, the earliest start time, which of course is 0. And we'll do the same thing for making the sandwich, and we'll put a 0 in. Now the process we're going to use here is called forward scanning. We look at what happens once the water is boiled. We know it takes 3 minutes, and the next activity that leads on from that is to add the coffee and the milk. So we can't add the coffee and the milk until that water is boiled. We can if we want to, but if we want to make a cup of coffee this way, we're going to add the coffee and milk second. Okay, so what's the earliest start time that we should put here? Well, given that the water could be boiled from the 0 minute mark as its earliest start time, and it takes 3 minutes, it makes sense that at the 3 minute mark we can add our coffee and milk. Likewise over here, the earliest we can toast this sandwich is going to depend on how long it takes to make the sandwich, which is 5 minutes. So that 5 minutes goes in here, and now we look at the end of our project over here, and we'll just put a square box here, and we'll look at how soon we can finish this whole project off. Now we can see that we have 2 activities that are coming in here. Where's that thing? There it is. So there are 2 activities that need to be completed before the project is finished. Now the coffee and milk were added as early as the 3 minute mark, and it's going to take us 6 minutes to add that coffee and milk for whatever reason. Maybe we're a bit slow. And to toast the sandwich, the earliest we could start doing that was at the 5 minute mark, and it's going to take 2 minutes to toast the sandwich. So it must be a pretty powerful toaster. So that's going to be at the 7 minute mark at which the toasted sandwich is ready, whereas the coffee is going to be ready at the 9 minute mark, 3 plus 6. So the earliest we're going to finish and have this meal ready is at the 9 minute mark. So I'm going to put a 9 here, and now I'm going to put a 9 here. This is the latest start time, now which sort of doesn't make a lot of sense for the last one because we don't have any more activities. So you can think of it as the earliest and latest start time at which you can get on with your life and do something else. So let's now scan backwards to find the latest start time of the activities. So the first thing we do is we look at this 9. We wanted to finish at the 9 minute mark. If we take off 6 minutes and go backwards, the latest we could have added the coffee and milk would be 9 minus 6, which is 3. So I need to put a 3 in here. Now let's go back along this path. From the 9 minute mark going back 2 minutes would make 7 minutes. So I put a 7 there. Now that 7 represents the latest time that I could start toasting that sandwich and still have it ready at the 9-minute mark when the coffee becomes available. 7 plus 2 makes 9. So in effect I have what's called a slack time here. At the 5-minute mark our sandwich is ready to be toasted, but I could just sit there daydreaming for 2 minutes before I put it on. As long as I put it on at the 7-minute mark, because it's going to take 2 minutes to toast, it'll be ready at the 9-minute mark just as the coffee is being finished. Now let's scan backwards to fill in these gaps here. So boiling the water. Okay, let's take our 3, the latest start time at which we could add the coffee and milk, and from that 3 we take these 3 minutes away, so we need to put a 0 over here. So 0 goes there, and likewise for the making the sandwich activity, let's take it from the 7-minute mark, take off 5, and we'll put a 2 in here. So what does that tell us? It tells us that, sure, the earliest time you can start making the sandwich is at the very beginning, at the 0-minute mark, but you could actually afford to wait 2 minutes before you start it. And at the 2-minute mark, 5 minutes to make the sandwich, that would take us to 7. And then at the 7-minute mark, 2 minutes to toast the sandwich, we'd still make it at the 9-minute mark. Now what's important here is, if we look at this pathway, we've got 2 activities which have a slack time of 2 minutes, making the sandwich and toasting the sandwich. But we can't use that slack time on both activities. Otherwise we're going to blow out the length of this sandwich making process by 4 minutes, and we don't want to do that. We can see it takes 5 and 2, or 7 minutes. We can only afford slack of 2 minutes to make it on time here for when the coffee's ready. Okay, let's look at a further example. Now this is a network where I'm going to put in some little spaces for earliest and latest start times, and we'll work our way through this network by forward scanning, and then we'll go back with our backward scanning to fill in all the numbers that we need. Alright, so obviously at the beginning we're going to start with 0, and we're going to look at our first 2 activities. Activity A and Activity B, well, they can both start, because they're at the beginning, they can both start at the 0-minute mark, so let's put in a 0 here and a 0 here. Let's work our way forwards. Okay, Activity A is going to take us 5 minutes. So if it starts as early as 0 minutes, takes 5 minutes, well, the earliest we can start Activity C is at the 5-minute mark. Whoops. So I'm going to put a 5 in here. So you can think of it as sitting here on this little spot here. Where are we? Getting a bit lost here, guys, sorry about that. So you can imagine you're sitting here on a cushion and you're waiting before you can start this Activity C. You're sitting here waiting, you're saying, well, what are we waiting for? Oh, that's right, we're waiting for this activity over here, which is Activity A, and it takes 5 minutes. So we're expecting it to arrive at the 5-minute mark, which it does. So the earliest we can start here is the 5-minute mark. Now let's just move along. Actually, let's go back over here to Activity B and do the same thing. Now Activity B leads into activities D, G and E. So all these activities are ready to go, but the person sitting here waiting says, well, what am I waiting for? I'm waiting for Activity B. It takes 3 minutes. So the earliest these guys can start is at the 3-minute mark. We need to put a 3 into each of these spaces. So let's do that now. 3, 3 and 3. So they're done. Let's fill in F now. Now if we look at Activity F, we can see that if we were sitting here waiting, what are we waiting for? We're waiting for activity C to arrive, we're waiting for activity D to arrive. What's the earliest activity C can start? The 5-minute mark. And it takes 4 minutes. So at the 9-minute mark, C will arrive. What about D? When will it arrive? It starts as early as the 3-minute mark and it takes 4 minutes. So that means it'll arrive at the 7-minute mark. It's actually going to arrive first, but we can't start activity F until they've both arrived. So the longer one is 5 plus 4 or 9. We're going to put a 9 here because that is the earliest we can continue on in this project with activity F. Now you might think, am I just randomly jumping around filling in boxes? Well, no, I'm not. I won't fill in a box until all of the activities that lead towards it have had their earliest start times filled in. So I can fill out activity I's earliest start time. And what else can I do? I cannot fill out activity J's earliest start time because I need this one here, I's one, filled out. Alright, so let's fill out I. You're sitting here waiting to start activity I. Who are you waiting for? You're waiting for F. Where are you, F? What time did you start? You started at the 9-minute mark. You're going to take 3 minutes. We'd expect you to arrive at about the 12-minute mark. So let's put a 12 in here. That's the earliest time we can get on and start the next activity. Whoops, let's just undo that. Okay, what about activity H over here? Who's it waiting for? Well, it's only waiting for E. E starts as early as the 3-minute mark. It's going to take 2 minutes, so at the 5-minute mark is the earliest we can expect to start activity H. Let's put a 5 in there. Right. Activity K, we can fill that in because the only one we're waiting for, sitting here waiting to start activity K, the only one we're waiting for is H. H started at the 5-minute mark. It goes for 9 minutes, so we're going to put a 14 over here. Now we're up to activity J. Now think about this. We're sitting here. Where am I? Over here. We're sitting over here. I'll get it in a minute. Sitting over here waiting to start activity J. Who are we waiting for? We're waiting for activity I. I started at the 12-minute mark. It's going to take 4 minutes. I will be finished at the 16-minute mark. We're also waiting though for this activity G. When did it start? It started at the 3-minute mark. 8 minutes further on it'll be finished. That's the 11-minute mark. So activity G will be completed at the 11-minute mark. Activity I will be completed at the 12 plus 4, 16-minute mark. So that's 16 goes here because that's the one we're waiting for. I is the slow coach. G will arrive first. I is the one we're waiting for. Let's put 16 into this space over here. Okay, so when is this project going to be completed? Well, activity J needs to be completed and activity K needs to be completed. Now J started at the 16-minute mark. 16 and 5 makes 21. K started at the 14-minute mark. 14 plus the 7 minutes it takes us to 21. So they'll actually both arrive at the same time at 21. Since this is the final activity, if we put it in a box like this, we'll put a 21 in there. And that's the earliest start time of whatever our next project is. Now to scan backwards, we put 21 in this box as our latest start time. So these two numbers are always the same at the very beginning and at the very end. Now I'm going to scan backwards. So what I do is I take 21 and I want to finish at the 21-minute mark. K is going to take 7 minutes. So the latest it can start is 21 minus 7, which is 14. So I'm going to put a 14 there. Whoops, take that away. Okay, what about activity J? The latest it can start is what we want. So we take the 21, take away the 5 J takes to do. The latest it's going to have to start is the 16-minute mark. So I'm going to put a 16 in there. Now notice it's easy to get confused with this stuff, so what I want you to remember is that when I take 21 and I take away 5, this number that I'm taking away is right next to the box that I need to put the answer in. 21, take 5, gives 16. 21, take 7 is 14. Okay, let's have a look a little bit further back in the network. Let's have a look up here. I take the latest start time, 16, and I'm going to trace back by 4, which means I put a 12 in here. Let's put a 12 in there. What else can I fill in now? Let's go back and fill this one in. So to fill this one in, you've got to make sure the one in front has already been filled in. 14, take away 9. Next to that 9 is this space. 14 take away 9 is 5. So I put a 5 in there. And what am I going to do next? What about activity F's latest start time? I'll take 12. I'll go back 3. That means I'll put a 9 in here. What about activity G? I can do that one now. 16, back 8, leaves 8. So I put an 8 in that box. Notice those two numbers are not the same. Let's talk about what that means in just a minute. What about this activity C? Alright, what does it trace back from? Back from this activity F. Let's take 9, the latest start time of F, go back 4, so we'll put a 5 in here. Let's put 5, there we go. Phew, there's a lot to fill in here. What about filling in this box here? So we trace back 9, we go backwards through the network, 9, take away 4, puts a 5 in there. Again, those two numbers are different. We'll talk about that in a minute. And what about over here? 5, let's go back through the network. 5, back 2 is 3, so a 3 goes there. And what about up here? 5, take 5 is 0. 0 in here. And the other one, we want to fill this one out. Aha! Now here's where we've got to be careful. There are 3 activities that trace back to here. So what we have to do is subtract 3 from each of them. The lowest number is what we're going to put in as we go backwards. You might remember when we forward scanned we put in the largest number, or the longest activity. Here we're going to go back and put the smallest number in. So 5, back 3 would be 2. 8, back 3 would be 5. And 3, go back 3 would be 0. So 0 it is. Okay, now I mentioned before that some of these activities have a different earlier start time and later start time, and this was one of them. I think that was meant to be a 3 there. So that 3 there and that 8 means that activity G, activity G, let's pause that for a sec. Sorry, hit the wrong button there. So activity G, there's a slack time of 5 minutes there. We can actually afford to wait 5 minutes. So G, the earliest it can start is a 3-minute mark, but you could actually wait till the 8-minute mark before you started it, and you'd still finish this project in the 21 minutes. Let's see why that's the case. Let's just follow this pathway from start to finish. So this activity B would be 3 minutes. Activity G would be 8 minutes. So at the 3-minute mark, plus 8 minutes, plus 5 minutes, what's that add up to? 8 and 3 is 11, and then that another 5 makes 16. Now notice 16 is 5 short of 21. Okay, so that means we've got 5 minutes up our sleeve. Where does it come from? Over here. Activity G did not have to start until the 8-minute mark. So we actually could have waited 5 minutes before starting it and still finish this pathway at the 21-minute mark, at the same time that these other two pathways of activities were completed. This one here and this one here. So this introduces the concept of the critical path. The critical path is the pathway that contains activities whose earlier start time and later start time are the same. That means, for example, H, the earliest it can start is the 5-minute mark, the latest it can start is the 5-minute mark. That means that we can't afford a delay, it's got to start straight away. K can start as early as the 14-minute mark, and it must start at the 14-minute mark. Otherwise, we're going to cause a delay in the project, and it's going to take longer than 21 minutes. So what we can do here is let's just trace out those critical paths. So this pathway along here is actually a critical path. And also, this path along here is also a critical path. If you add up the times of the activities along both of those paths, you'll find they're both critical. They're both going to take 21 minutes. Let's look at the first one. We've got activity A, 5. Activity C, 4. That's 9 minutes. 3 more is 12. 4 more for this activity, that's 16. 5 more makes 21 minutes to complete that pathway. Same for this one. 3, 2 for E, that's 5. 9 for H, that's 14. 7 for K, 14 and 7, 21. But look at this pathway. 3 and 8 is 11 and 5 is 16. This is not as critical. Alright, that's why we can afford a delay at this point here. In fact, look at activity D. There's a delay here. That's one of the pathways I haven't traced out. So we could trace along this pathway and add up the times, and we would find that we've got, look at the difference in those, 2 minutes. We'd have 2 minutes up our sleeve. Excuse that glitch. Now let's just continue. So to sum up, the critical path is the path that takes the longest time. Any delays for activities on the critical path will cause the project to take longer.